Hello there, my name is Ajiboye Isaac, and this is part 3 of our notes on partial fraction. In the first part, we discussed resolving complex fraction into partial fraction, where the complex fraction has linear factor denominator. In the second part, we discuss quadratic factor denominator, and this time around we're going to look at numerator with higher degree, complex fraction with numerator of higher degree. So our learning objectives: at the end of the lesson, learners should be able to simplify partial fraction into single complex fraction, resolve complex fraction with higher degree numerator into its partial fraction, and solve problem of partial fraction. So what we want to achieve here majorly is to be able to resolve a complex fraction with the numerator, where the numerator has a higher degree than that of the denominator, into partial fraction. So key vocabulary words: linear factor. A linear factor is a factor with degree 1 as highest degree on its variable. Example: 2y plus 3x is a linear factor. Why? Because the power on the power on variable y and x are 1. Okay, algebraic fractions. Algebraic fraction is a fraction with variable and constant. An algebraic fraction is a fraction with variable and a constant. For example, 2x plus 3 over x minus 1 raised to power 2. So this is an algebraic fraction simply because we have variable x and constant 3 on the numerator, and we also have variable x and constant minus 1 on the denominator. So that makes it an algebraic fraction. Coefficients. A coefficient of a variable is the number attached to the variable. Coefficient of a variable is number attached to the variable. For example, 2x in the algebraic fraction example, 2 is the coefficient of variable x in the numerator. 2 is the coefficient of variable x in the numerator. Also, we have constant. A constant in an algebraic expression is a term that does not have a variable. The term without a variable is a constant, or the term in the expression whose value does not change is called a constant. Whereas a variable in terms is a term in an expression whose value is liable to change. For instance, in the example of algebraic fraction, x is a variable, right? Fraction with higher degree in numerator. Whenever there is a higher degree in the numerator, the fraction is first simplified by long division method, and the resulting fraction can therefore be resolved into partial fraction. Generally, if polynomial p is divided by a divisor d, the result will therefore be equals to quotient q plus r over p, whereas the p is the divisor anyways. Okay, so we have p is the polynomial, d is the divisor, q is quotient, and r is the remainder. An example will help us understand this better. Resolve x cubed plus 2x squared minus 8x plus 7 over x squared minus 4x plus 3. So to resolve this, we'll first of all divide this whole fraction. That's the first thing we'll do. We'll divide the fraction, all right, by long division method. As you have learnt in polynomial, how to conduct a long division method of polynomial. So what we do here is I will put the denominator outside, and the denominator is x squared minus 4x plus 3, and the numerator inside to perform a long division method. And also you will notice that the first thing to do is to use the first or the highest degree variable to divide the highest degree variable in the numerator. So that is, we'll do x cubed divided by x squared. The x cubed is the highest degree variable in the numerator, while the x squared is the highest degree variable in the denominator. So therefore, we have x cubed divided by x squared, and that will give us x. Now, the step after that is to use this x. This x that you got will be written as a factor. And then you use this x to multiply the divisor. All the terms in the divisor, mind you. So you use x to multiply x squared. That will give us x cubed. X times minus 4x. That will give us minus 4x squared. And x times plus 3. That will give us plus 3x. Then we subtract this result from the polynomial. So when we subtract this result, we have x cubed minus x cubed will give us 0. Then we have 2x squared. We have 2x squared minus 4x squared. That will give us 6x squared. Then we have minus 8x minus 8x minus 3x rather. Minus 8x minus 3x. That will give us minus 11x. And because we are dealing with a trinomial divisor, we'll therefore bring the 7 down to complete the cx squared minus 11x plus 7. Now, again, we will divide x squared. We use 6x squared divided by x squared, and that will give us 6. So we use 6 to multiply. That will be 6x squared minus 24x plus 18. Then again, we subtract. If we subtract, we'd have 13x minus 11, because we have 6x squared minus 6x squared will give us 0. Minus 11x minus 24x will give us plus 13x. Then 7 minus 18 will give us minus 11. So our polynomial our complex fraction, when divided, will give us x plus 6, which is the factor gotten here, then plus the remainder over the divisor, which is the remainder is 13x minus 18 over x squared plus 4x minus 3. Now this 13x minus 18 over x squared plus 4x minus 3 will therefore be resolved into partial fraction. And so the first thing to do there is to first check if the denominator x squared plus 4x minus 3 is factorizable. And of course it is. So you factorize it. And when it is factorized, it will give us x minus 3, open bracket, x minus 1. So our 13x minus 18 over x squared minus 4x plus 3 will therefore be equal to 13x minus 18 over x minus 3 times x minus 1. So when resolved into partial fractions, you give us a over x minus 3 plus b over x minus 3. Now we'll multiply both sides by the LCM of the denominators, which is of course x squared minus 4x plus 3. So when you open the bracket, when you expand, you have 13x minus 18 equals to a, open bracket, x minus 1, close bracket, plus b, open bracket, x minus 3. When we expand the left-hand side, we have 13x minus 18 to be equals to 8x minus a plus bx minus 3b. So what we do then next is to factorize. Collect like terms, I mean to say. So we have 13x minus 18 equals to x, open bracket, a plus b minus a minus 3b. After that, we'll compare coefficients. On the left hand side in this place, the coefficient of x is 13 and the coefficient of x here is a plus b. So therefore, we have 13 equals to a plus b when we compare the coefficients. We'll call that equation 1. Also, on the left hand side, the constant is minus 18, whereas on the right hand side, the constant is minus a minus 3b. And therefore, our equation 2 will be minus a minus 3b equals to minus 18. All we need to do at the junction is to solve simultaneously by adding so that we can eliminate variable a. So when we add a minus a will give you 0. Then we'll have b plus minus 3b. And that will be equals to 13 plus minus 18. So finally, minus 2b will give us minus 5. And b will equals to 5 over 2. Now that we know that b is equal to 5 over 2, we can substitute that in equation 1. And that means our a will therefore be equals to 13 minus b. And that is equal to 13 minus 5 over 2, which will give us 21 over 2 on simplification. So the partial fraction of 13x minus 18 over x squared minus 4x plus 3 is equal to 21 over 2 over x minus 3 plus 5 over 2 over x minus 1. What we have just done is to substitute a and b. So therefore, the complex fraction x cubed plus 2x squared minus 8x plus 7 over x squared plus 4x minus 3 will now therefore be equals to x plus 6 plus 21 over 2 open bracket x minus 3 close bracket plus 5 over 2 open bracket x minus 1. Then we'll close the bracket. So this is how to deal with complex fraction where you have the numerator to be of a higher degree than that of the denominator. I want to believe that this explanation is clear. So you should use the same explanation to solve this classwork. You will first need to perform a long division method, then before you then resolve into partial fraction, and then attempt this assignment. In this assignment, I have the WAEC question, the just written WAEC question of further maths exam. So I have the numbers there. You can confirm to check. Please attempt. You can see that you're already solving WAEC question. So attempt and forward your attempts to me for guidance. And I also want to commend the effort of those that have been attempting the classwork and assignment. You're on the right path to success. I would also like you to go to my YouTube channel for more videos. You can as well subscribe on my YouTube channels to get notification of video uploads as I upload videos on a daily basis, just so that you can improve in your mathematics skills. Also, you can share the video to your friends and other learners. You can also make comments on the videos. Tell us how the videos have helped you to understand mathematics better. And also, we render services for private tutor, all right, private lessons. You can as well contact us via my WhatsApp number. Thank you for listening.